So we'll start with this idea of what is a program. So if you take any program, this program is a sequence of bits, very nice. So what does a program do? It's a representation of a program. When you think of the representation of a program is a sequence of bits. But semantically speaking, what does a program do? So any program, what it does is it takes input, some input, and does some computations based on the input, and it generates output. Any program, it takes, it consumes some input and does some computations based on the input and generates output. We can also say a program transforms the input into output by following a set of instructions. For example, when let us consider a program which transforms a color image into a grayscale image. You all know a color image, right? So when you take a pictures and all, you have a color image, and then you have a grayscale image also. Like for example, you can do some transformations using your mobile phone, software on the mobile phone, and then get a grayscale image. Okay, it gives you some interesting look to your photo. So if you look at this, so that's an example of a program which takes color to grayscale. So what is the input to this program? The input to this program is a color image, and the output of this program is a grayscale image. Hold on to your questions. So there are good questions. And so how is a color image represented? So you have a color image. You know, in a color image, it has three components in it, RGB channels, red, green, and blue. So a color image has three channels, RGB channels. We call it as three components or three channels. And you all know, like, you know, when you buy a camera or mobile phone, you see what is the resolution of the images. Yeah, don't worry about it. So it's essentially, if you take your color image, it has three components in it. So your image is represented as a collection of rows and columns. Your image is represented as a collection of rows and columns. And this is a red. This is a red channel or red matrix. R stands for red. So it's a red. And every pixel here, you know, like this is, you know what is a pixel? In an image, every dot, it is represented as a pixel. And then you have green channel. Yeah, I'm just using some, this is a green. Red, green, blue. So if you look at each pixel in your image, it is a combination of, The red component, it has a red component, it has a green component, and it has a blue component. So the top, let's say if your image, the image I, so 0, 0, that is 0th row, this is the 0th row and 0th column. This is the 0th row and 0th column. You are, don't get distracted. Yes, so stay here. So I request you. Your image is, how do you, if there is an image, what happens? Your image is represented. It is divided into rows and columns, and your image is a collection of pixels. Your image is a collection of pixels. So here, this is a pixel, this is a pixel. So everything is a pixel here. Every cell in this here, it's a pixel. The only thing is, in order to represent one pixel of a color image, we need three components. One is the red component. So associated with this, there are three components associated with the pixel of the image. The 0th component, the red component, the green component, and the blue component. Can you think of this grid as a matrix? Your image is represented as a matrix. Your image is represented as three matrices: red matrix, green matrix, and blue matrix. And if you want to know in your pixel, like for example, if you take a picture, look at the particular point in your nose, and that particular point in the nose, it could correspond to 100, 1000 pixel or something. All right. Are you all with me here that your image is it's a grid of pixels. Your image is a grid of pixels. And it is not one grid. There are three grids: red grid, green grid, and blue grid, or red matrix, green matrix, and blue matrix. And now we want to write a program. Yeah, you can think of it as math matrix also. Don't worry about it. For the time being, it can even be a math matrix. Why not? Okay, essentially what happens is, when we think about problems, we think of your problems in your matrix space or some mathematical thing, and then you map it into computers in some form. So when there are RGB components and your display, your monitor, it uses these values to render that particular pixel on your screen. This is one particular representation. Rinda has a good question. Yeah, you can assume a pixel as element of your matrix. So let's take a step back. Don't worry about this representation system. All I want you to understand is your color image is a grid of pixels, and it's just not one grid. There are red grid, green grid, and blue grid. In order to completely describe this, let's say the top leftmost corner of the image, we need the corresponding pixels from all the matrices or grids. Yeah, some kind of overlap happens between these three matrices to generate the final image. Are you all with me till this point? Doing good? Some level of abstraction. So now, in order to convert this image, this RGB image, into a grayscale image, we want to write a program, RGB to gray. And this RGB to gray program, it takes these three inputs, okay, the RGB channels, and then it generates one channel or one matrix. This is a grayscale matrix. This is a grayscale matrix. Grayscale image, or this is what gets generated. And how do we combine these three things? Like for example, let's say this is ith row and this is jth column. This is jth column and this is ith row. So in the grayscale image, let's call it as GI. The I comma jth component or the I comma jth pixel in the grayscale image is given by no. So R of I comma j. There are different ways of combining them. G of I comma j plus B of I comma j. We take the sum of them and divide by 3. So we are merging the RGB channels and we are taking the average of them and we are computing a pixel of the grayscale. Here, we did a dumb, I wouldn't say dumb thing. So we kind of used equal weightage for all the three components. But if you go online, like if you go check in Wikipedia, you will find different formulas for it. Like maybe 0.6 times red pixel plus 0.3 times green pixel plus 0.1 times blue pixel, so on and so forth. There are different ways of combining these RGB pixels. But the point is, your grayscale image is some function of the RGB pixels. It's just an example. Thank you, Shreyash. So it's average. It's easy to. Okay, so what is the right way to combine the RGB pixels to obtain the grayscale image? It's you study in the image processing course. This is not a course on image processing. Okay, so the idea here is the I comma jth pixel of your output is a function of the I comma jth pixels of your red, green, and blue channels. Grayscale is not black and white. From 0 to it is different levels of black and white. That's why it's called as grayscale. Are you with me here? That each pixel in your grayscale image is a function of the corresponding pixels in the RGB channels. That's all. Whether you take an average of it or you do R square plus G cube plus whatever any function, all those things are possible. We can do it. There is no logic here, Patanjali. We are just what we are doing is in order to compute. So what do we have? This is your red. Let's see if you look at this one. This is your red pixel. This is, and then you look at your green. This is your green, and then this is your blue. And this particular pixel here, I don't have gray here. This particular pixel here is a function of this red dot and the green dot and the blue dot. Some function. Yeah, grayscale images doesn't have RGB channels. That's true. Yeah, thanks, Rohan. So Rohan is helping me out that the color pixel is a function of if you think of the color pixel CP, it is a function of the red pixel, green pixel, and blue pixel. This function can be anything, so let's not worry about it. No, this is not color pixel, this is gray pixel. This is the gray pixel GP is a function of red pixel, green pixel, and I have a conflict here, name conflict. GRP, gray pixel. Gray pixel is if you know gray, photo, gray photo. You take your mobile phone and apply, take a picture on any picture, and then you can apply a transformation on it, and you get a gray picture. What do you mean by color? Monochrome. Maybe you're just complicating stuff. Monochrome is one color. So don't worry about it. It's not even negative. You didn't see a grayscale. Did you see old movies? What is Charlie Chaplin? What is it? Charlie Chaplin, all very old movies. They are all gray, movies in black and we call them as black and white movies, but it's just not black and white, right? You see a spectrum from zero to from white to black. That's not black and white, Revant. So black and white, we call them as black and white movies, but if everything is black and white, it will be horrible. Okay, so this is what it is. I think you are missing the point. Do you want to learn programming or you want to learn image processing? Tell me. First, tell me you want to learn image processing or programming. Okay, so if you want to learn programming, believe me, or for the time being, trust me that you combine red, green, blue pixels in some way and generate a gray pixel. Exactly. So let's move on. So now this is an example of a program. Okay, this is an example of a program which takes as input and then generates a color image as input and generates a grayscale. Let us use abstraction. Exactly. Thank you, Ashmit. And then there is one more interesting case, which I've emphasized in the last class also. The same instructions we use on all the pixels, source image input pixels, to generate the output image. That is the same. That is what? That is where these control transfer instructions. So that is what control transfer instructions means. Okay, what are control transfers? So the same operations we are performing again and again on different pixels of the image. Okay, let's read this. Awesome. So now, do you get this idea? Are you able to appreciate this idea that the same operations are applied again and again and again to different pixels of the image? So this is where the power of computers, the power of programs come. When the same operation is being applied again and again and again, then computers come in really handy. If every time you are doing a different operation, then that's going to be a tricky thing. Okay. So in this context, yeah, I'll hold on to my, I have, so let's say if the I comma jth pixel, if you apply a different transformation for every pixel, do you think it is easy to write a program? You mean like, for example, in order to generate the I comma jth pixel, you are using some function Fij, then do you think, no, then what happens is for every pixel, no, there is a different function Fij, then it is going to be difficult for you to write a program. Some other examples of programs, so some other functions are different for every pixels. So some other examples are like, for example, you can have a program sum n, which takes as input n, and then it outputs sigma I is equal to 1 to n I. So this is yet another example. Or you can have a function is prime, and given, and it outputs two things. One is s if n is prime, and no if n is composite. So you get the idea, right? Every program has input, and it does some computations based on the input, and it generates output. So now what we will see is we will write our first program in today's class, and see the steps involved in the compilation of the program and what happens under the hood. We look at a bunch of interesting ideas now. So in order to write, I'm using my Linux machine. So yeah, it's up to you. So you can follow along with me. And in order to write your program, you need to use an editor. And the editor that we are going to use is Visual Studio Code Editor. VS Code Editor. You can follow along with me. It is fun. Did you all install, anyone yet to install VS Code on your system? Oh. So now once you open VS Code, so now, so if you go and search here extensions, if you press this button extensions, you will see C, C++, or if you search for C there, you will immediately get the C, C++ IntelliSense. You should install this extension. You should install this extension. So this is useful when you write your programs. It is very useful when you write your programs. So there is this extension. So if you see here, this one on the rightmost side, Control Shift X if you press, or if you see here, you see if you press this one, yeah, and you get this one, and you search for C, and you get this, and you have to install the C, C++. Yeah, it's on the left side for some. Actually, by default, it will be on the left side. I kept it on the right side. I configured by machine so that it's on the right. If you are not able to do it now, it's okay. Just see what I am doing. You can do it later also. Just follow along with me, guys. If you are able to follow, you follow, but later you can do it again. All right. So now what we are doing is we will. So here we go and say, I'm not audible. Voice became low. How about now? Is it good? Okay. So now I edit a new file, and then so I will use this file to type a uh, to type our new program. And first I want to name this. So I use Control S, or you can use File and go save as, both you can do. And I'm creating a new folder for your class, CP Computer Programming, Monsoon 2021, Section B, create. So in this folder, I will write a program called as hello.c. It's happening here. So we are typing our first program. Don't try to understand what this program, what it is, but we'll look into all these details. So please type in the program. Don't copy paste. It will be nice to if you type in the program by yourselves. So once you install that extension, as you type in, you will keep getting suggestions, and you can use these suggestions nicely. Okay. These are called as autocomplete suggestions. So our first statement in the program is hash include stdio.h, and then we have void main. So now this is a empty function. I saved it using Control S, and you can use again. You can go here and do save. You can do that, or you just use Control S. And we have the statement printf hello world, and then /n. So what this program does is, you remember our program is nothing but a sequence of instructions. In this program, we have only one instruction in the form of what is called as a printf statement on line 5 of this program. So on line 5 of this program, you see, this is line 5 of this program. So we have a printf statement, and it prints hello world onto the screen. Followed by that, you see the /n. No? /n means after you print hello world, go to new line. Okay, go to new line. So that's what /n means. So that's all this program does. This program doesn't do it doesn't take any input. It's not doing any processing. All it does is it is just printing onto the screen this string hello world /n. /n means new line character. Say /n is new line character. That is after you print, like in printer, let's say if this is going to printer, then you print hello world and then you have to go to the new line, right? In order to indicate that, hey, please go to the new line, we use that /n character. So what does line 1 does, etc.? Just focus on line 5. When the program executes, control goes to line 5, and the printf statement prints hello world onto the screen. Voice gone. For some reason, my audio is automatically, I'm not. Again gone. Hello? Why is it going down? Hope it doesn't change. Okay. Apologies, something weird happening. So Raven has this question, what if you want to print a /n? We will see. Okay. // Okay. So now the question for you is this hello.c program. No, no, I'm not pressing any, not at all, anything. No, no, what is happening is there is a but it is automatically, again it went down automatically. Let's try now. Maybe it's because of the Bluetooth. Okay, let's see or test our luck. And if there is a problem in you are seeing, right, what I'm doing since this is all. No, I'm increasing the mic sensitivity, or you are able to see the screen top right. I'm increasing it and it is going down. And it is going down automatically. This didn't happen before. I switched off. Sorry. Check, check, check. Check. Okay, let's keep going and then, disable the auto mic volume in Zoom settings. Is there something like that? Oh, let me try that then. Hello. In the Zoom settings now I removed auto mic volume change. Is it better now? In the Zoom settings I changed it. Auto mic I removed. Okay. So let's see how far this lasts. I'm very sorry, guys. This is first time experience. I taught multiple semesters, first time seeing this. That's what happens when software becomes super smart. Okay, great. So now my question for you is this hello.c program, where is it residing? Is it in the RAM or is it in the hard disk? Hello.c, where is it? RAM or hard disk? So your hello.c program, it is on the hard disk, it's not on the RAM. So in order to see what is going on, let's open the terminal. So terminal is our best friend. So let's go to the directory CP21B. This is the directory in which now we stored our file. And when we do ls minus al, you can see that hello.c program is created. This file is created at time 12:37 on November 27th, and it has 64. The size of it is 64 bytes. So your hello.c program is on the hard disk. It is on the hard disk. You just enter the program. You enter the program in a file. The processor doesn't know anything about it. It doesn't know that you have even created this program at all. Okay, your operating system doesn't know that you have created this program. So all they know is it's just you just created there's a file called hello.c and it is staying on your file system in this particular directory. Now if you just check file hello.c, you will see that hello.c is a C program and it's a ASCII text. VS Code is in RAM but not your C program. Anika. So VS Code is currently running. That the instructions of the VS Code are in the RAM, but not the text that is present in the within that VS Code. And you see this thing called as ASCII text. See what happens is your program is stored as a sequence of bytes on the hard disk. Your program is stored as a sequence of bytes in the hard disk. Gone? No? So your program is stored as a sequence of bytes. So your program is stored as a so hash I C like this, sorry. Here are my drawings. So these characters, one character after another, your program is stored in the hard disk. Don't worry what the first line is. Okay, don't try to understand the program. Just follow my line of thinking. The objective of today's course is not to understand what first line is and all. We have typed in a program and that program is stored as a sequence of bytes. Every character in the program has an ASCII encoding. Like for example, the character A, it is encoded as it's a sequence of 8 bits. Like it could be something like this. Character A is encoded as a sequence of 8 bits. Similarly, this pound symbol, it will have some, it is encoded as a sequence of 8 bits. So every character here, it has a 8-bit encoding, and this encoding we call it as ASCII encoding. I would like you guys to, not all of you, to focus on what I'm telling. Okay, so you can don't get distracted. So most important idea, your program is stored. Your program is stored in the hard disk. This is your hard disk. Your hello.c is residing in the hard disk as a sequence of characters, ASCII characters. And for every character, space, left parenthesis, right parenthesis, everything will have an 8-bit encoding. Are you all with me on this one? This idea that your program is represented as a sequence of ASCII characters. Sequence of ASCII characters. Your program is represented, every character in your program, it has an 8-bit encoding, which is called as an ASCII encoding. And your whole program is written as a sequence of ASCII characters. Okay, so that's what it is. So now, in order to run the program, we want to run the program. Okay, so the program, it's this C program your processor cannot understand. This is not a language which the processor can understand. So we have to transform this into a form which your processor can understand. That is the next job for us. So what do? So we have to use compiler. So GCC hello.c -o hello. So now we have compiled the program hello.c, and what the GCC compiler does is it transforms the C programming, the instructions given in the C programming language into a form which which the processor can understand. Okay. So my question for you is the generated we call hello as executable because that is something which your program, your processor can execute. Is hello present on the RAM or on the hard disk? Is the file hello, this one, is it present on the hard disk or? So no, it is still present on the hard disk. So what happened just now? This is the what happened just now is this. So you have your thing. This is your hard disk. This is your hard disk. You have hello.c, and this hello.c got converted to hello, and this hello is still present in the. This is converted to hello by the GCC program, but hello is still present on the hard disk. Are you with me here? That the instructions of that hello.c got transformed into a form which is ready for execution by the GCC program, but it is still on the hard disk. So now what happens is, if you give the execution, when I say now, when I am giving this program for execution, then what happens is your hello program gets loaded into RAM. It gets loaded into RAM. The instructions of hello gets loaded into RAM. This is loaded. And then what happens is this program gets executed by CPU. Are you all with me here? Hello.c is, we edited the program hello.c in the VS Code. We used GCC to transform hello.c to hello. And then when you give the program, when we now press enter, what happens is hello, the instructions of hello gets loaded into RAM and the program executes. So now press enter, you will see hello world got printed on this. // means that in the current directory, // means in the current directory, look for the file hello, which contains the instructions of the program that I would like to execute. Are you all with me here? This what is happening here? This is very important. So very important. So hello.c is on the hard disk. We used VS Code to enter this program. We used GCC to transform hello.c into hello. Hello contains instructions which your processor can understand. And then you give hello for execution. The instructions of hello got loaded into the RAM. And the CPU then executes the instructions of hello. And if you see file hello, you will see a bunch of things. You will see a bunch of things. And among them, so this is the type of this file is called as ELF file. Okay, it's called as ELF file. And the important thing that you have to notice is this is called as a x86-64. x86-64. That means the processor on my machine, it understands a instruction set, it understands a language or what is called as an instruction set architecture. Instruction set architecture. Instruction set architecture, ISA. And so the compiler transforms the C language statements into a sequence of instructions from this x86-64 instruction set architecture. Don't worry about ELF, just focus on this x86-64. And that is the language which your processor understands. So Harshit, your machine is Mac machine, right? M1 processor, yeah. So if we have a Mac M1 processor, the language which the M1 processor understands is ARM64 language. And the language which Intel processor understands is x86-64. So the compiler translates the source C language program into instructions which that particular processor can understand. In order to understand this a bit more, let's look at this story. Okay, let's pay attention now. Don't worry about ELF. Okay, so what I would like you to do is the questions that you have, you make a note. Focus on what I am telling. Otherwise, you'll get lost because the whole system is very complex system. You cannot understand all of it in a single shot. We take bits and pieces and try to understand it. Yeah, Harshit gave an excellent thing. x86 for Ryzen processors also you will see x86-64. Yes. Okay, or AMD 64 maybe. Yeah. So GCC just minus G. Okay. Yes, both hello and hello.c or now pay attention to me, guys. Pay attention. So what your compiler does is, if you see line number 427 here, you have a print statement. Your compiler translates your printf statement into a sequence of these 5 instructions. And these are the instructions which your processor can understand, which your x86, which your Intel processor can understand. These instructions, they are not understood by an M1 processor which is there on a MacBook. Are you with me here? These are the instructions which your processor can understand. So your compiler translates this printf statement into this sequence of 5 instructions. And the important thing is what you are seeing here, LEA, call queue, NOP, these things again the compiler, your processor doesn't understand. The equivalent encoding for them, it will understand. Like for example, the encoding for no op instruction is 90 in hexadecimal form, but in binary 90 is nothing but like this. So your NOP instruction is stored in 1 byte of memory. This is 1 byte, 8 bits. So whenever the processor looks at this bit pattern 1001, 4 zeros, then that means it's a no op instruction, and that's what the processor does. And similarly, pop instruction is also encoded using 1 byte. Red Q is also encoded using 1 byte, but LGI instruction is encoded using 5 bytes or rather 7 bytes, and call Q instruction is encoded using 5 bytes. So this one, if you see this one, how many? 1, 2, 3, 4, 5, 6, 7. So there are 7 bytes. So 7 bytes. So LEA instruction is encoded using 7 bytes, call Q is encoded using 5 bytes, NOP in 1 byte, so on and so forth. And that's what your compiler does. Your compiler translates your source code, C program, or it could be C++ program, C, C++, Java, all these things, Python, your processor doesn't understand. But the corresponding compilers translate them into a form which the processor can understand. Okay. So, and when you give the program for execution, so the instructions of the program are loaded into the memory and the processor executes. Are you all with me on this example? Doing okay? You understood completely, right? And that's all for today. What is the summary picture? I'll just draw the summary picture again. So you started with hello.c, and then we used compiler, the GCC compiler, to generate hello. If you go look at the hello, this is what you see, all the encodings for the instructions. And then when you give that command for execution, your program goes to RAM. The instructions of the program goes to RAM. Okay, so hello is present here, and then your CPU will execute the instructions of your program. You don't need to remember encodings, just remember the concepts. This is the summary picture for today's lecture. Are you all happy? 12:59. No, you don't need to do it side by side. Don't worry about it. What is this seed? See, this is the language. Okay, let me go draw one more picture here. So your processor is here, you are the programmer. Your CPU or processor here, you are the programmer. So there is a language, you are talking in C language. Okay, you are talking, let's say I don't know Hindi, you speak in Hindi and I only know English. What do we do? Okay, and the processor understands x86-64. You understand what I'm saying? You are writing, so processor is talking in one language, understands one language, your program is in some other language. So you cannot, so you have to rely on some tool to translate this language, this source language, into a form which your processor can understand. And the thing which does that job for us is the compiler. In this case, we are using GCC. x86-64 is not the version of CPU. No, it's not the version. GCC translates the C code to x86 assembly language. Thank you, Ajit. Yeah, hello is the executable file. There is a question is whether hello is the executable. Don't worry about this, guys. This is an encoding of, because all these things, they have to be, at the end of the day, they have to be encoded. This column, if you see this column, this is the column which the processor understands. And this is the column, this is there for our human readability. This is for human readability of what is happening. So this, so your whole program is encoded as sequence of bytes. Instruction set architecture. x86-64 is called as instruction set architecture. Those 7 bytes are the encoding for that LEA instruction. Those 7 bytes, Ramandeep, those 7 bytes are the encoding for this. You know, this LEA instruction is encoded using those 7 bytes. Yeah, when you type something in MS Word, the text you type is stored in HDD. I would say you review this We are not looking at the code. So you have to see what is the point of today's lecture. Today we are not, the point of today's lecture is not to understand no, a C code. The point of today's lecture is when you write a program, it gets stored on the hard disk. And then you use a compiler to translate it into a form which your processor can understand. And then you load the program. Okay, and then you load the program into RAM, and then the execution happens. My speaker is not working. You should type in your question as everyone. What is we follow PTP? Anusha asks when you directly click the execute button. So automatically the VS Code will do it for you. VS Code will invoke the corresponding underlying thing. Yeah, exactly. Once told you. So it does the same thing, but it doesn't show the command. Yeah. Without main memory, all the instructions of the program should be in the main memory. Without main memory, there is no. That's what the summary of last lecture, right? All the instructions of the program, they should be in the main memory. When will we get the recording? So I will stop here. Stop my recording.